Now we're going to start discussing how to measure radiation. One of the most common ways to measure radiation in a large area is a Geiger counter. What happens is, as the radiation passes over this open screen area, the gas inside reacts with it, and electrons are given off. Those electrons are then carried through the wire and amplified so you can actually hear like a clicking sound. And the amount of clicks tells you how much radiation is there. The more clicks, the more radiation. There are several units for measuring the radiation. The very first one was the Curie. That is basically saying how many atoms decay in 1 second. That's still used, but these have actual more biological meaning. The rad and the rim. The rad measures the radiation absorbed by tissues of the body. So this number could actually change quite a bit depending on what tissue you're referring to and what animal, what species you're referring to as well. Rim takes into account the radiation as well as the type of radiation. So for instance, here are the common units, what people usually refer to them as. The Curie, disintegrations is referring to how many atoms are breaking down at once. Notice it's a really big number. Well, the scientific community decided to break that down into becquerels, who is actually another scientist that did a lot of nuclear research. And so those two things are equivalent to each other. Then the rad, the radiation absorption dose, which is affected by the tissues of the body, also has the unit of the gray. You see that 1 gray is equal to 100 rads. Then rim, which is probably the most common that I've seen in biological senses, is the rad. But then we have this factor here that's getting multiplied by how deep the penetration is. With whatever type of radiation it is. So an alpha particle would have a different factor than a gamma particle. Often they use millirims. So it's these rims here. But we put it in milliterms. Milli just means 1,000, which is why you have 1,000 here. It makes it a little bit easier to deal with as far as numbers are concerned. So there's a lot of different places you can get radiation. You can get it from natural sources like cosmic rays. Get it from the air, food we eat. You get it from medical sources. I'm pointing this one out specifically because there's a whole area of medicine that's revolving around nuclear chemistry. If this stuff interests you, it's possible that you can specialize in it as a nurse and possibly make more money. So something to consider. Other sources, people get really bent out of shape out of power plants, but that's actually a very minimal choice, a very minimal rim. They get really scared because they think of things like Chernobyl, where disasters have occurred, and so they think of the worst case scenario, which isn't a bad thing. It is what it is. Air travel actually gives you more radiation than nuclear power plants. And then radon, this actually varies a lot depending on where you live. So remember, LD50 means the lethal dose for 1/2 the population, for 50% of the population. Notice how it changes. But remember, this is based upon the type of radiation as well as the type of tissue. So it's a little misleading, but 500 rem is where the lethal dose is for humans. Around 300, where the dog is, around 300 rem is where you start losing your hair and stuff like that. So maybe that's where they start, maybe that's the maximum amount they use for radiation therapy for cancer. Because I know a lot of people who have cancer end up losing their hair when they go through radiation therapy. Right, and that is how we measure radiation.